Welcome to your Chapter 9 notes for 9.1, and we'll also do a little bit of 9.2 today. Today we are finding the vertex and axis of symmetry. We're going to have a lot of vocab today, but it's all really good information that you need for this chapter. So we're going to find out what are the key parts. I will go fast. Make sure you pause when you need it. I just want to make sure I get through all of it, but I know you can pause it to give yourself time to write things down. We are only getting to level 2. Tomorrow we will begin graphing. So what is a quadratic function? You should know that from last chapter. We called quadratics are things with a degree of 2. What does that mean? They have x squared in there. Okay. All of these are all examples of a quadratic function. They might look a little bit different. Some have 1 term, some have 2 terms, some have 3 terms. But all of them have a degree of 2. Biggest exponent is 2, so that's why they're quadratics. Standard form, and you've seen this maybe a couple times, the teacher might have shown you, just looks like this. We know standard form goes from x squared to x, and then a number at the end. But sometimes the b is 0 or c is 0. But the main thing is that there's always an x squared. My favorite word in math is what a graph of a quadratic function is. So they always look like U's. I like to say they look like happy faces or frown faces. So they might look like this or they might look like this. They are called a parabola. Do not say parabola. Your math friends will laugh at you. It's parabola. Okay? And then one special trait that a parabola has is that it is symmetrical, and you can see that when you look at it. It's cut in half here. We call that line the axis of symmetry. So symmetry means it's even on each side. So the axis of symmetry is what cuts it in half. In this case, how do you write the equation of that axis of symmetry? Well, it goes through where x equals 1, 2, 3, 4. So the axis of symmetry is x equals 4. So some more stuff about the axis of symmetry is that we can tell just by looking at the equation. So for example, if I were to give you y equals negative 2x squared, I know that it's going to be upside down. So if your a value, the number in front of x squared, is negative, then the parabola opens down. I like to remember negative people frown. If a is positive, then it opens up. Positive people smile. Okay, so it looks like a smiley face. Another word is the vertex, and the vertex is that point in the middle of your curve. So it's the point in the middle. It's your highest or lowest point is another way to think of it, depending on if it opens up or down. The vertex is always, if you think about it, any U-shape, thing like that, if you cut it in half, the axis of symmetry is always going to go through the vertex. So the vertex is always on the axis of symmetry. Okay. So we want to talk about max or min. Max is if it's a high point, min is if it's a low point. So if you look at this graph, it is the highest point. So it is the max. In this case, it is the lowest point. So it is a minimum. Minimum means the lowest. Like minimum to pass is a 65%. It's the lowest you can get. So just a couple ones to go over, just to get some practice. So in this case, where is the axis of symmetry? Axis of symmetries are always x equals, and then I'm just going to count over 1, 2, 3, 4. Like if I were to draw in a line here, it would be right here. That line is at x equals 4. The vertex is this point. Remember, that's x and that's y. So when you label that point, you go to the right 4, so x, and then up 2. So that's your vertex. It's the highest point, so it is a max. And it opens down. It's going down. In this case, I'm going to draw in my axis of symmetry. It's right there. Where is that at? It's where all the x's equal -2. The vertex is at, if I count over, I would go -1, -2, and then up 1. At least that's where I meant to be. I can't really see it, but it should be at -2, 1. It is a minimum because it's the lowest point on that graph, and it opens up because the arrows are pointing up. Part 2 is going to be finding the vertex from the equation. You do need your calculators for this, so please take yours out. So it was pretty easy to find it from a picture. You just look at it, oh, what is that point? But now if I give you an equation, how do you find that? So we do have a formula, and it is x equals -b over 2a. Just a formula, a is whatever's in front of x squared, b is whatever's in front of x. So here's my example. I have y equals 2x squared plus 8x minus 4. So a is 2, b is 8, c is -4, not that I need it. So my formula would be, I'm going to plug in 8 for b, so -8 divided by 2 times a is 2, and I get -8 over 4, which equals -2. So my axis of symmetry is x equals -2. So if I were to graph this, I know my axis of symmetry over there. I also know that it would be flipping up, so it'd be something like this, but that's more tomorrow stuff. So in order to find the vertex, remember the vertex is always on the axis of symmetry. So if x equals -2 is my axis of symmetry, my vertex has to have -2 as an x. How do I find y? We plug it in. So to find the coordinates x, y of the vertex, your first step is find x using -b over 2a. That's the same as your axis of symmetry. Okay. And then you are going to plug that into the equation. So this is the same as the problem on the last slide. So we already done step 1 on the last side. We got x equals -2. Step 2 then, I'm going to plug that in for x. So I don't know why yet, but I'm going to plug in, make sure you use parentheses, and plug it all in. I'm going to pull up my calculator. You can plug this all into your calculator. Sometimes you can do them in your head too, but I'm just going to do it. So it would be 2 parentheses -2 squared plus 8 parentheses. Make sure you do negative instead of minus if it's a negative that you're plugging in. And then this one is a minus sign, not a negative. That's a -4 at the end. So you kind of have to be able to tell the difference. And I get -12. So my vertex, if this is -12, my vertex is at -2, -12. Your vertex is always a point, so you always need x and y. So here's what this might look like. Find the axis of symmetry on the vertex. So again, step 1, your axis of symmetry is x equals -b over 2a. So I'm going to plug in. Remember, a is here, b is here, c is here. So -6 divided by 2 times a. Figure out the bottom first, that gives you 6, and I get -1. So that's your axis of symmetry, is x equals -1. For your vertex, again, we know your vertex is a point. I already know x, it's -1, but you're going to plug that in for x in your equation. So y equals 3 parentheses -1 squared plus 6 times -1 plus 7. You can plug it into your calculator. You can do order of operations, whatever you want to do. 3 parentheses -1 squared plus 6 parentheses -1 plus 7. This one would be pretty easy to do in your head too, but just make sure you do order of operations if you do it in your head. and you get 4, so y equals 4.